Now let's take a look at this example. We want to find the domain of f of g for the function f of x equal x squared minus 4 and g of x equal square root of 4 minus x. Okay, domain of f of g means the domain of f of g of x. Okay, so in order to find the domain of f of g of x, we will have to look to the domain of what? Domain of g first, and then the domain of g of x, f of g of x. Okay, so let's first of all find the domain of g. Domain of g. So this is the even radical. So when you see the even radical, we will have to set the expression under the radical greater than or equal to 0. And then we add the x on both sides. We will have x 4 greater than or equal x, which means x less than or equal 4. So the domain of g is x less than or equal 4. Now we're going to find the output of f of g of x and see what happened. F of g of x is mean we're going to g of x will become the input of f of x. So we're going to have to replace all the x value on the function x by the expression of g of x, which is square root of 4 minus x and the whole thing square and then minus 4. So turn out we will have 4 minus x minus 4, and that gives you negative x. All right, so function f of g of x is equal negative x, and we can see the domain right here is actually all real number. However, we have to consider the domain of the input as well, which is the g, x less than or equal to 4. So turn out the domain of f of g is whatever the value of x that less than or equal 4. Okay, so it means your x can be any number, any real number, but it's much less than or equal 4. Otherwise, it won't become the composition function. Okay, so that's how you determine the domain. So two things that you have to consider for the domain of the composition function. First, you have to find out what is the domain of the new input, which is the g, and then find out what is f of g of x, and then see is there any restriction for x. Take the intersection, you're gonna have the domain of f of g of x. All right, so let's take a look at an extra example. So if I have the function f of x is equal 1 over x and g of x is equal x squared minus 4, and I want to find the domain of f of g. Okay, so first of all, f of g is f of g of x. So the input is g of x, it means we will need to find the domain of g of x as well. So what is the domain of g? So in the function g of x, we can see this is polynomial. So when it's a polynomial, the domain is all real number, right? It's all real number. Now we're gonna evaluate or find out what is f of g of x. So f of g of x is input. So we're gonna replace all the x value in my function f by the input g of x. So it's gonna be this into here. So my new expression for f of g will be 1 over x squared minus 4. Now look at the function f of g of x, we have 1 over x squared minus 4. To consider the domain of the composition function, we also have to look at the final expression as well, and look like this is the rational function. We need to exclude the denominator. So x squared minus 4 cannot equal to 0 or equal 0. We will have x squared equal 4 or x equal plus and minus 2. So in the domain of the final expression is x cannot equal to plus and minus 2, and the domain of g is all real number. So we have to conclude that domain of f of g is actually all real number, but x cannot equal to plus and minus 2. You can use the set builder notation to write the domain. This means x is all real number. This is mean x is all real number. Such that x cannot equal plus and minus 2. set builder notation. Or you can write at because your x cannot equal -2 and 2, right? So you're gonna have everything else but except -2 and 2. So your domain will be -infinity to -2, -2 to 2, or 2 to infinity. Okay, so that is the domain of f of g. So not all the time we will just take a look at domain of g. We have to take the intersection between the domain of g and the domain of final expression, and then take the intersection of that. Okay. Now, what about if I want to find the domain of GOF? So if you want to find the domain of GOF, GOF is actually G of f of x. Okay, so f of x now become the input of g. So it means you're gonna have to find the domain of f. So domain of f is what? If you look at the f function, you can see that is the fraction, right? When it's a fraction, you have to set the denominator cannot equal to 0. So we have x cannot equal to 0. And then we're gonna find a new expression for GOF. We're gonna have to look at the function g and then put in, take the function f, put into the replace the x value on your function g. So we will have to take all of this and replace to the x value. So we will have 1 over x replaced x and then square minus 4. Simplify the expression, we have 1 over x squared minus 4. From this final expression, we also see that x cannot equal to 0. So therefore, the domain of GOF gonna be x cannot equal to 0. Or the other way to write is x in R and x cannot equal to 0, such that x cannot equal 0. Or the interval notation is -infinity to 0 and 0 to positive infinity. Okay, so this is called set builder notation. Okay, so there are two different notation that you can use.